G'day and welcome to the video where we will talk about capacitors in DC circuits. So firstly, capacitance is the ability to hold an electric charge and is measured in farads. The charge of a capacitor is the product of the source voltage multiplied the capacitor's capacitance, and this is measured in coulombs. Capacitance is also directly proportional to conducting plates of the capacitor as well as its permissivity, whilst being inversely proportional to the distance between the conducting plates. Capacitance can be increased by introducing a dielectric material also. In terms of energy, a capacitor shouldn't dissipate any. Instead, it will store this energy in the form of an electric field between the two conducting plates. This energy will then be redistributed back throughout the network once the supply voltage has been disconnected or switched off. So we call resistor capacitor circuits RC circuits, and we determine the capacitors of a series circuit by this formula here, and is an example to show that. For parallel, it's the opposite, much like the difference between resistors in parallel and series networks, but it's just the other way around. So capacitors in steady state mean they are fully charged, and these diagrams will show that the capacitor will actually act as an open network once steady state has been achieved, where there will be no current, but the voltage will be the same as what's passing through the 18 ohm resistor. And we're talking about time constants. Steady state is achieved over time, and we use time constants to measure the time taken for a capacitor to reach this state. Tau is a time constant with units of time, and is the product of a network's resistance and the capacitance of a capacitor. During the charging phase, the rate at which a voltage increases when the capacitor is rapid at first, but slopes off over time as the device reaches maximum capacity. This trend follows with the rate at which current flows to the capacitor also, as these graphs can show. So once we disconnect or turn off the source voltage, the capacitor then becomes the device with the highest potential and will actually discharge this energy back into the network. So here's a quick exam style question with a couple of parts. Part A asks you to calculate the time constant of this circuit here, and it's as simple as adding the resistance together and multiplying it by the capacitor of the capacitor. And we get an answer of 0.5 seconds roughly. And part B asks for you to determine the expression of the voltage VC after the switch is closed, and is as simple as just subbing in the values from the diagram, and you have your expression. Thank you for listening.